share with a lot of others, and it's to make 3D printing the most value-adding manufacturing technology this century. And what does that mean? Well, it's a vision, so it's a little bit fluffy, but basically with value adding, I mean either you save time or money, but most importantly that you can create things that you couldn't with previous manufacturing technology. That's what, for me at least, is very exciting. I started this business with a friend, Anders, well, it was late 2013, and the first year we had a turnaround of about 5 million Swedish crowns, and now some 4.5 years later we have a target of 85 million, and we're almost 20 employees. It has not been easy, but it has at least been fun. Sometimes, not many times. So, and we just started at a satellite office in Malmö, and we're happy to have been able to hire a lot of people and you know, hopefully given them interesting jobs in this. Yeah, what we work with, these type of solutions, we have sold a lot of desktop 3D printers for professional use to a lot of different industries. Here are some examples: Ultimaker, Formlabs, and now the latest additions, the Markforged machine, which you can see outside in our booth. And we also do a lot of training and workshops to our customers. We do not work only in Sweden. We have a network of resellers. So we are distributors for many of these brands. So we have resellers both in Sweden, but also in all of the other countries in Scandinavia and in Baltics. And we do not sell directly outside of Sweden. In all other countries, we have specific resellers because we think it's important that you get service and support in the local language close to where you are and so on. And for certain industries as well, like for the dental industry, it requires a lot of specific knowledge to that industry. So what we do is that we train the resellers in the technology of the machines and how to do service and repairs and support. But then they support their customer with their applications, which are specific to that industry. So dental is a little bit specific. Otherwise, there's of course a lot of general knowledge. And as you can see, the different types of businesses that use 3D printing and additive manufacturing they're quite diverse. And what's fun is that it grows every year. So every year there's some kind of 3D printing technology or some new material that unlocks some new industry. So all of a sudden they can save time or money for their application or make something that they couldn't before. So currently we have customers that use it for manufacturing, like jigs and fixtures. You can take the car industry, for example. They use a lot of tools in their line to produce cars. And usually a new model might take 3 months just to order all of the specific jigs and fixtures for that specific model, you know, that they're slightly changed how the car looks every year and so on. And Volkswagen, as an example, in Spain, they produce 7 different cars there. And they have saved last year over 300,000 euros by using 7 desktop machines instead of ordering these parts from external suppliers. So that's just one simple thing. You might not, you know, manufacture the actual car parts that much yet with 3D printing, but just as a tool to speed that up is interesting. Then, of course, engineers, it says here, well, it's about general product development and to design any part or anything which speeds us up with the prototyping and fast iterations. So that's helpful in all kinds of industries. Yeah, dental, that might go for dental labs or even clinics now to replace where you would previously have maybe plaster or something for a workpiece for fitting, all kinds of dental work, but also more and more to actually replace the actual things you have in your mouth, like retainers or these splints, things like that, because there are now materials that are biocompatible that you can print even with a desktop machine. And then architecture, it helps a lot for the architects for internal communication when they discuss how the light should fall on a building or something. It used to be a profession, or still is, I would say, model building, but more and more they can do a lot of things just by having their own machines. And then, of course, in actual construction, they're becoming like these big concrete printers. Still a little bit early, but research and education, of course, used everywhere. I think we sold 1/3 of all of our machines to somewhere in the educational framework or technical universities. And then the last one there, maintenance and spare parts, that was a little bit of a surprise for me. That came the last 12 months. Last year, I was asked to do a talk on 3D printing of spare parts, and I thought, wow, that sounds interesting, but I didn't really know about it or like how it was used. But then I heard about the companies doing that, for example, the Dutch Navy, and they also saved millions of Swedish crowns in 1 year, printing pretty simple parts that were no longer available for their ships, for example. And they could print them and use them with regular plastics. So yeah. So this is just to say that there's such a huge demand for this technology already. Let's see. Yeah, we also develop our own products. One of them is this ruby tipped nozzle made for printing very hard materials. For example, carbon fiber, or even harder. Like this one was developed by this guy Anders Olsson, who's here today. So I have a separate talk about that at 6:50. Something all around the world. So this we produce it in Sweden, and I think we've sold around 10,000 or so of these globally. And that's also something I had no idea. If somebody told me you will be working with some kind of ruby tips 4 years ago, I was like, no, I don't think so. So there's a lot of new things just possible by the use of 3D. This is something we have in Stockholm, 3D Meetup Center. And this is where we do training for customers, for example, for specific machines, if it's Ultimaker or Formlabs or something else. We also train resellers, and we welcome visitors there, because we also have technologies there that other companies provide. For example, Höganäs Digital Metal, VBM Components, Prototal, who does printing services. These are many companies that might not have a presence in Stockholm, but since Stockholm is so big with so many people, we want to be able to show off most of the technology families. So yeah, they have little display booths for each technology. So if you are in Stockholm, you're welcome to give us a call and book a meeting. So what else? Yeah, this is actually the start when it was a hobby. This is in 2011 when Ultimaker released their first kit for 3D printing. So there's a little time lapse that we made. Let's see. There's supposed to be some kind of music here. Yeah, maybe it doesn't matter so much. The thing is, before this time, I worked 20 years as an IT consultant, and I got a little bit tired of it, so I wanted to learn something new. And I've always loved tools. And I saw this thing on the internet, like a tool that couldn't produce anything, basically. And I thought that was so appealing. So yeah, I and my friend, we ordered this kit, and we spent the weekend. Yeah, that's this weekend building this thing. I think it was about 800 different parts. I mean, probably you know about it if you also built your own kits. And of course, it didn't work after it was assembled. So it took a few months to do it, actually. But it was a lot of fun. And I think we spent around 1,000 hours or so the first year just to learn the technology. And it was not so easy to I mean, the slicers were very basic back then and so on. But it was a really nice learning curve. But then also we realized that it's probably not for most consumers yet, because takes too much time and so on. But it's really, you know, useful for doing prototypes and this. Of course, now every year the machines get so much more reliable and useful and more. I want to talk. I mean, this will be pretty focused on Sweden, and in Sweden we have an inter-organization called SVEAT. How many of you heard of SVEAT before? A few of you, okay. So this is Svensk Additive Tillverkning. It's a non-profit organization consisting of a lot of different members. So you see here a mix of really huge companies like Tetra Pak and Volvo and and also smaller companies and 3D print specific companies. So I think now maybe it's around 70 members or so. But I can tell you that all of these are employers of 3D printing specialists, the people working with it, and it's growing all the time. And the purpose of this interest organization is actually to make Sweden more competitive internationally when it comes to 3D printing and additive manufacturing. So if you want to check it out, you can just go to sveat.se. And we do these type of conferences where we just share news on what's happening or research and so on. Also a lot of universities there. So the board of that is a mix of a few different universities and also some big cars and some smaller companies like Fjällverkstan and a few others. So it's a nice mix, you know, of input between the needs of big companies, small ones, and research organizations. I thought I would just briefly mention a little bit about what's in English usually called the promises of 3D printing. Perhaps you all already know about them, but then it will just be a little bit repetition. So, and this is promises compared to the traditional manufacturing. So let's just go there. So one of them promises is zero lead time. That basically, instead of taking months to build a prototype or something, you can do it immediately. Of course, it will never be zero, but it will go towards that point. So you will save a lot of time. So this is a really basic example, which actually is from my partner in business, Anders. He has another hobby, which is designing board games. So this is a game called Emily Lönnberga. That's from the little kid that does these wooden figures. And this game is about making as high as possible a staple without them falling down. So in this process of doing this, Anders and his brother, they 3D printed a lot of figures, and then they could quite quickly, with groups of children, just ask them to try them out and see how difficult it was with a certain shape. And then maybe they noticed, oh, the hand needs to be bigger, otherwise it's too hard or too easy. So this process, after they finished with actual figures, they could send them off to China and then to have them produced, I think, 10,000 copies. And it was all within 1 year. And the thing is, that year the prototyping was really fast. The other thing was like contractual things with their company that should produce the game and so on. So it's a pretty straightforward example. But of course, it goes for really whatever design the process you have, that you save a lot of time. So I would say that promise is already, it's in effect and very much used. Here's another one: try ideas at low risk. And this I see really as a way of startups or small companies of trying out ideas. So this is an example of a Kickstarter, like a self-watering pot that is now being sold and injection molded. But this would not have existed without 3D printing, because they did the prototypes on a desktop 3D printer. And you can afford to try out things before investing in something more expensive, like molds and tools for injection molding, for example. And then to the right here, there are now materials available, so you can actually make a small rough pre-production run of something that might need to be injection molded because of costs. So this material, for example, can withstand the a few hundred degrees at a certain pressure, so you can make some food. So things like this come all the time. Let's see. Yeah, this one, manufacturing complexity is free. This is what many people think about when you think of 3D printing. You can make any shape and so on, and for 3D printer, it's just following whatever rule. And of course, this is not entirely true. There are shapes that can't be done with 3D printing and so on, but there are very many shapes that can only be done with 3D printing, that can't be done at all with a mold or with a CNC machine or turning and so on. And this is really what can save, what can create new products and save a lot of time and so on. And the challenge here is that the designers need to rethink. If you have been designing or like in CAD for many years, then you might be locked into the constraints that you need to have right straight angles or something like that. Whereas a kid or someone in school might have this imagination and they would just create any shape. So it's a little bit of reprogramming. So that's and every year the technology gets a little bit better, so you can make more and more complex shapes for free, so to say. Yeah, this is another thing that's really interesting for maybe the bigger company that makes really complex machines and so on. This is a rocket engine from NASA that used to be 150 parts separately that they need to quality assure, manage, and then put together somehow. And they could make it into 2 parts by using 3D printing. So they actually save a lot of money. Of course, a rocket engine is really, really expensive. So that's not for most people. But the concept in itself, that you can save a lot of time and money by making everything and bends and shapes instead of having to weld them together or otherwise. The other one here, less waste byproduct. It's I think this is a fastener for an airplane, and this one above it uses 30% less material, but it's just as strong as the lower one, which is traditionally made. And for airplanes, every kilo you can save in the air is thousands of dollars over the lifetime of the plane. So that's why the aerospace industry and airplane industry is investing so much into additive manufacturing. New materials or even create new metamaterials with 3D printing. It's not really been used that much yet, but I hope it will be. This example was with boron carbide filled ABS. Boron carbide is an extremely hard material, like third hardest known material. So there's diamond and something else, and then there's boron carbide, which means that if you use a brass tip, it will wear out in no time. So that's actually the original idea why the ruby tip was needed. It actually even wears the ruby, but quite slowly. But the properties of this material, this is mean to slow down neutrons. So this is used by Uppsala University for different experiments. But now it's also being used by ESS in Lund to, all kinds of installations where there's neutrons, like radioactive, could be nuclear applications and so on. And before using this is, since this is so hard, it's really difficult to manufacture in any other way. And otherwise you might need to use like poisonous cadmium or things like that. So just an example that you can use materials otherwise not possible. And for the future, I think combining materials so you can get different properties is even more interesting. Like you saw with the E3D machine, you have like 4 different extrude lines, and combining them with different geometry, you can get like self-repairing materials, or who knows, some kind of magic. Bioprinting, that's quite specific, but I mean, you can print biomaterials and tissues and things. I don't know too much about that, but I know that it's also a very interesting subject. So this one says zero skill manufacturing and mass customization. Yeah, this is an example and that's an industry that completely has switched to 3D printing more or less. And this is actually because it saves time, and it's quite small, so you can produce them a lot, and they're each individual to each specific person. So they already make sense, even though it takes a long time to produce something with 3D printing. So the serious skill manufacturing there is that before this, you need to have really specific knowledge, the workers who did them manually. But now the machine does it. Of course, you need someone that knows how the machine works and everything, but that's more a generic knowledge instead of an application-specific one. Mass customization, the thing that you can individualize a lot of things, and the machine can produce many of them at the same time. So let's see. Yeah, this is also very nice. Precise physical verification, a lot used in medical applications. So if you take a scan of your body or something, if you have an injury and a surgeon needs to perform an operation on you, they can use your anatomy and reduce risk by printing jigs that have the correct angle to minimize risk and so on. This has been used for all kinds of operations, from heart surgery to cancer and everything. So I think this is really, really nice application. The issue with this is that there are so many tests required before you can have something close to the human body, so it doesn't get contaminated and so on. So, but I think it will be huge in a few years. I think maybe most of you knows how the technology works. So of course it's layers upon layers with the slicing process, and that's actually the same for all additive technologies, or 99% of them anyways. You might have seen this picture, I don't know. I think it's a quite good overview from 3D House, because there is a standardization committee that have divided additive manufacturing in 7 different technologies. It was done a few years ago. I don't know if there is a new revision, but if you look at the different terms used by the manufacturers, you can be kind of flabbergasted. So I usually use this myself, just to remind myself, oh, what was that? Oh, it was that family, okay. And so if you go to that, I think it's a nice summary. But usually I like to divide it into 3 families instead, because it's a little bit easier, because usually it's some kind of extrusion based, which, I mean, 99% of the machines out here are. Or the photopolymerization, the liquid based ones, usually SLA or DLP, or some kind of ink jetting. Or the last one, which is based on powders, which would be metal powders or polymer powders or gypsum or things like that. And they are, of course, used for different things. I would say the last one is the one most used for mass production of parts in quite expensive machines. These can be really cheap and also really expensive. And these are a little in between. Most of the things printed still, I mean, in terms of materials, is different types of polymers, plastics and rubber. But I mean, metals is growing hugely. I think it doubled in just last year from the last Polish report. And then you can print all kinds of composites and things. So things are progressing. And there's, I mean, connected to the business, it's of course, you can work with any of these things. This is just some examples of machines using the different ones. Big powders, the machine, the art gun from Mellenbaum that was bought by GE. Like some kneecaps, I think. This with one, the desktop, SLA machines. And yeah, at the end, as you know, yeah, Okay, so now here's a little bit of Swedish, but it says like training or like competence development in 3D CAD and additive manufacturing. So I'll talk a little bit about why you need to design for additive manufacturing, and that's a lot connected to maybe metal additive manufacturing. And then after that, I'll talk a little bit about what form of training is available in Sweden, as I know. So this is something I have learned from Ljungstig, who is a professor at Lund in product development, specialized in additive manufacturing. He has a really good knowledge of additive manufacturing worldwide and like how to fix costs. So he's been kind enough to learn this. These are actually really old figures by now. This is a bonus report from 2 years ago. So I think that this is like up here somewhere. I didn't actually check it yet. But the thing is that it's growing a lot, and the thing is, why isn't it growing more when it comes to the industrial part of it? What Olaf Diegel thinks is that there's a high cost bill because many people and companies who are trying it out, they're just replacing like an original design and just moving it to additive manufacturing, and then it will be very expensive because you really need to use what's unique about additive manufacturing, and this is what's called design additive manufacturing. So here is some examples for metal machines. So they cost a lot of money, of course. These are some examples, like from $500,000 up to like over $1 million. And yeah, depending on where in the world it is, of course, there's some kind of hourly running cost for the machine. So let's say it's somewhere between $50 and $100 per hour. And here's an example of an object. So this is a manifold, so it's a pipes connected internally. And this for 10 by 10 by 10 centimeters. And he has here calculated the cost per layer to produce this object. Yeah, this is $5 then, and it has taken an average of the hourly cost here. So that's how this looks on design for additive manufacturing. But this, you can see the internal structure there. That's actually what's needed to make the function work. So they took the same design and just shelled it out, and you see all of a sudden you have 24 cents per layer instead of $5 per layer. And then you need to have some support material, which also takes time to remove afterwards. So you can actually redesign it to a smart use of support material. I mean, this is not a consumer product, so in this case, it doesn't matter how it looks. It can look like that and it can function. And comparing the costs here for the initial design compared to the optimized one, you can see it goes from $15,000 to $2,000. So that's a huge factor. So this is really one example of why it's for industrial uses needed to, you need to rethink how you design it for additive manufacturing. And I mean, that's happening now. So here's another example from Tetra Pak. When they produce the milk cartons and these type of beverage cartons, they have an induction heated sealer that seals the package. And I think that the little hole in the middle there, that's where the cap goes, I think. So when they do this, it goes very, very fast. And when it heats, it also needs to get rid of the heat somewhere. So they had a project where they wanted to use an additively manufactured part to get rid of the heat better. So you see these cooling channels there. The original was drilled with straight channels, and then it was plugged and so on. But then you could, if you used it additively, you can have this. You didn't need to have straight channels, and you could have yeah. And also, they didn't need to be completely round. They could be oval, so it can, disperse the heat better. So this is the heat distribution when looking with a thermal imager, and you can see that it's a lot better at transporting away heat in this scenario. And yeah, here's also a close-up of that. And this means that this is not in production yet, or maybe it is, because this is an example that's now maybe 6 to 12 months old. But it means that, I don't have the figures, but I think he told me that they think they could increase the production by 30 to 50%. I think if you could, instead of making whatever 1,000 per minute, I have no idea how many, but if you could increase that by 30 to 50%, how much money they can save on that. Yeah, it's an interesting example. Yeah, so what types of educations are we in Sweden? Well, not too many. This is one example. The same professor there, he actually has a course on the university. So if you work somewhere and you want to learn about additive manufacturing, you can take a pretty big course there called Design for Additive Manufacturing. And I think this was done last year and now this year. I mean, that's kind of expensive. Maybe not for company. I think it's around 20,000 Swedish crowns or similar. But that's like a specific course if you're already a designer and you just want to, learn more about how to design for additive manufacturing. Then you have the vocational educations. And I know there has been 3 different ones in Sweden, 2 in Stockholm area and 1 in Eslöv, which is also an online education. And 2 of them are still available. And this one, in Eslöv, the online one, I don't know too much about it, but I know that Per from RAPS, so if you go to the booth of RAPS, you can ask him more about this one. I can just read here and translate. It just reads about the different types of business that use 3D printing. So it says, the rubber, plastics, automotive, workshop, casting, medicine industry. You use it for prototypes, but also for prostheses, airplane parts, jewelry, art and design of different kinds. And I can verify all of these and more. It's just fun to see that, the different vocational educations, they also see this from the need from the industry. And then we have one where I know a lot more about, and the reason for this is that I'm also part of the advisory board for this. And they have quite an extensive. Is anyone here from Accenture, by the way, that has been on this training? Because it's been running for 2.5 years now. So, and they just made a little movie. I wonder if I can get some sound here. That would be nice. Okay, so sound here for one. Nobody's here from Unida, right? It's fjärrkontrollen. Bakom lås. Yeah. But you kanske kopplar till mikrofon. Yeah, but actually now that I remove this, the problem should be with my laptop actually. I think the problem is that I used to work in IT for 20 years, so let's see this. Okay, sorry.
Du har projektorn som ljudet igång, så du måste aktivera projektorns ljudcykel. Eller datorn.
Okay, that's interesting. How do I do that? I don't know. Let's try it without. I can try after we finish it. So this is just a short 2-minute movie about this education, and part of it is subtitled. So Stefania here is an architect from Sweco. Yeah, you can. That's actually subtitled. She's actually here now, I think, or will be here later tonight. So at Sweco, they use it a lot for Sweco architecture, design for buildings and everything. But of course, Sweco is a huge company also working with engineering and civil engineering, things like this. And, what she talks about is that they are also having good use of the students that do that training from example technical. This is from the actual school. There are about 30 in every year. What does this? Yeah, sorry, that's no sound at all. Yeah, I can see if we can get some the rest of it finished. But that's a 2-year education, and in total they have, I think it's between 4 and 6 months of actual training internships. And they do, they have been everywhere in Sweden. They've been to Höganäs Metal, is quite close to here. Been to Arkham, they've been to a lot of different architect offices. We've had probably 4 or 5 interns with Kedjeverkstan, and we hired one of them. We are actually hiring now. So we have about 4 roles now this year that we would need. So if any of you are looking for new opportunities, we're looking for a service and support technician that will offload our current support engineers. It has to do with service on the phone, email, and repairing machines and spare parts, things like this. We're also looking for more, what would you say, analytical business analytics, someone to help out with procurement and see what products sells well and what does well, and pricing, things like this. The third one there is for the marketing team, someone that's experienced with layout and design. The last one, technical sales representative, since we're selling more and more solutions and more capable machines and big machines. So I had hoped we had the new complete job descriptions on our homepage. I think only one of them is there. So, but if you have any interest, come talk to me afterwards or send an application to the address there. Yeah, I don't know how we are on time, because this was I never did this particular talk before, but 16:41. Yeah, maybe I think it was until 5, right? So then we can just do a longer Q&A session here. So yeah, I do like that. I thank you for this, and please just ask away if there's anything you want to ask about.